Hello again. Today we're going to be talking about how to confirm continuity over an interval. So let's get started. We're going to start with a piecewise function here. It's got three pieces depending on what values of x you want to try and plug into that function. Just to make it look a little simpler, I've graphed it here on the right. And so there's a few things that I notice. Even though there's a break in the domain at x equals -2, we can see that the function is still continuous there. So that problem is solved. The limit exists, the function exists, and they're equal to each other at that point. So I can say that it is continuous there. But I do have a jump discontinuity at x equals 0. I also have a removable discontinuity, informally called a hole, at x equals 1. And then the last thing that's going to affect continuity is this vertical asymptote at x equals 2. So the continuous part at x equals -2 is not going to affect my domains over which this is continuous, or the intervals over which it's continuous, but x equals 0 is going to cause a problem, x equals 1 and x equals 2 are going to cause problems. So the function is continuous from -infinity to 0, then starting again just after 0 to 1, then from 1 to 2, not inclusive, and then from 2 to +infinity. So that's where the function is continuous. Let's talk about another example where I've got a function. It's not piecewise, but there are certain things that affect the domain, and that's going to affect where the function is continuous. So let's look at it piece by piece. The first part of the sum of these functions has an x squared minus 9 in a square root in the denominator. So I know that in order for this to be continuous, that's only going to happen where x squared minus 9 is greater than 0. That happens when we are plugging in x's between -infinity and -3, not including -3, and from 3 to infinity, not including +3. So those are the only x's that are going to make this function continuous, because those are the only x's where the function actually exists. The second term is going to be continuous. Because I'm taking the ln, I can only take the ln of positive numbers. So that means that x over x plus 5 would have to be greater than 0, and that only happens over the intervals from -infinity to -5, not including -5, and from 0 to infinity, not including 0. So the function itself is going to exist when those two restrictions overlap each other. So it's going to be the intersection of those. And so that's going to be from -infinity to -5, union 3 to infinity. That's the overlap of those two. So that's when that function is going to be continuous. It's not going to be continuous anywhere else. So that is defining continuity over an interval. If you have any questions on that, please let me know, and I will see you tomorrow.